Let us begin the session on computational thinking. In this particular video, I'll be discussing about what exactly is computational thinking, what are various components of computational thinking. But first, we need to understand how it all evolved. It started way back somewhere around in 1960-65 that we need to build machines which are capable of thinking like humans. But now we are doing the other way around, that let us now instill that thinking in humans, that they start thinking like machines or computers. It all came into picture by virtue of the evolution. If I talk about the evolution of computers, they all started with ENIAC, a humongous room-size kind of a computer, and then it reduced, or it basically got evolved to a system or to a place which can be worn on a wrist. If you see today, your wristwatch or smart wristwatch is capable of computing, is capable of connecting to the entire world. This is the evolution which happened because of the miniaturization. But along with this, it happened so that when the miniaturization of computation was happening, the same time the miniaturization of thinking was also happening. People were becoming more and more dependent, or rather the cognitive load was transferred to machines, reducing the capacity and capability of people to think. In this change or in this evolution, we might have built the smarter machines, but we have also slowed down the minds. Let us now look to what exactly computational thinking is. But before that, I have a point that thinking cannot be taught. Be it critical thinking, be it logical thinking, be it design thinking. Thinking cannot be taught. Thinking can only be experienced. So during my entire sessions, I'll be talking about building experience rather than giving lessons or giving theoretical aspects of what thinking is all about. Let us first look to an experience. As a principal or as a leader of your institute, if you are planning an annual day, and as a teacher, if you are planning your lecture, what basically you do is you break the entire plan into small little components so that you can delineate, you can associate people to perform specific responsibilities when you're planning for your annual function. When you're planning for your lecture, the entire lecture of maybe 40 minutes or 50 minutes, you divide that entire plan of yours into smaller segments. The scientific association of this can be very well explained. That if you see a Boeing aircraft, do you think that that Boeing aircraft is built in one go? No. There are small segments which are built together and they are joined together to form such a big aircraft. The same is the example. A state, let us take this country. This country is divided into states. Then states are further divided into districts, which are further divided into maybe tehsils or wards or sectors like that. Why are we dividing a bigger thing into smaller chunks? I can give you a very good example that because of the division of country into states, into districts, into wards, into colonies, and further micro divisions, the COVID-19 vaccination happened seamlessly because we divided the entire bigger thing into smaller chunks. So planning goes to micro level. It started from the bigger thing and then it was planned through the smaller thing. The same is done when we are building an aircraft, and the same is done when we are planning for annual function or when as teachers we are planning for our lectures. Now this is known as decomposition. The very first tier or the very first pillar of computational thinking. This is known as decomposition, in which you divide a bigger task into smaller segments or smaller chunks so that it becomes easier, it becomes more strategic to accomplish that particular task. I'll give you second experience. Let us look to a picture shown onto your screen. If I ask you to identify whether this is a male or female, you will soon come to a conclusion, yes, this is a female. And when I go deep into my query and would ask you who all these two celebrities are, you will actually look to it with a very critical, very deep-rooted eye, and then can give me the answer that celebrity on top is this, celebrity on bottom is this. What did we do? When I asked you the very first question, that whether this is a picture of a male or a female, you were looking to the looks and the attire of the individual or individual's morph in picture. You were looking to the eyebrows, you're looking to the eyelashes, or you're looking to the makeup, and then you decided that this is most probably, or this is by virtue of all the confirmations, a picture of a female. In true sense, what do we do when you see the weather report on your mobile? It is basically extracted. There is no way, there is no means of predicting the tomorrow's temperature mathematically. It is possible. Same is the case with when we are talking about IPL as a game, or maybe FIFA now coming up as a game. All the players keep track of the opponent's party's players' style and the way they pass on the balls. This is nothing but you're identifying a pattern. When you're looking into the picture of an individual or the morph movie star's picture, you are patternizing. You were creating a pattern of eyebrows. The weather in your mobile device also keeps the track of the pattern of previous years and the pattern of the entire GIS maps which are around. For IPL or FIFA matches, people look to the patterns that if this is the bowler, what kind of balls that bowler puts in or bowls in. If this is a player, what kind of passes that particular player relies while playing a football match. In the terms of technology or in computational thinking, this is known as pattern recognition. The third experience is around you. In your kitchen, there'll be there'll be microwave oven available. What do you do with that microwave oven? Now, with that microwave oven, you take a dish, or maybe if you want to warm or heat some dish, what do? You open the door, put the dish inside, and put just simply the time for which it is to be operative, and then you push start. You're least bothered about what is magnetron, how this particular microwave works, how the microwaves are coming from left or right, or they're coming from one side, or how these microwave things are doing. You're not bothered about it. You're just simply bothered about the functionality of it. Meaning thereby, you're actually not bothered about the trivial things, the things which are not necessary for it, and you are primarily focusing on the functionality of it. The best example around you is your mobile phone. You do not have to bother about whether it is having a patch antenna or it is having a cord antenna, or what kind of battery it is having, or what kind of processor or what kind of operating system it is having. If you're a little enlightened kind of an individual, you may look to it, but it is not needed to know about them. The second instance is about your car. You're driving that car, you are more focused on the steering, the gears, the clutch, and the brakes kind of thing, and accelerator. You're not bothered about what kind of engine it has, what kind of cooling mechanism it has, what kind of electrical wiring it has. Now, this is where the third pillar of computational thinking comes into picture, and that is known as abstraction. In this particular pillar or in this particular ideology, you remove the noise, you remove the triviality, you remove things what are not needed for that particular function to happen, and you just simply focus on the main functionalities of it. The fourth experience, which I'm going to talk about, think of a scenario that along with me there is a celebrity who's actually delivering this particular session. He's sitting by my side. That celebrity is 6 foot 1 inches tall and has got a French cut beard. Yeah, I know. It came to your mind and you might have reached to a particular celebrity. But when I say that that celebrity has got hairstyles like me, now you'll be guessing. Now you'll be guessing all across around. Wild guesses would come, X or Y or Z individual, but you might have never thought of Dane Juan. You might have never thought of Diesel because he was not stored in your mind. In this exercise, what we did, when I said there is a celebrity, your brain removed all the other individuals and only the celebrity packet was there for your understanding. When I said he is sitting by my side, all the ladies who are celebrity were out from your mind. When I said he's 6 foot 1 inches tall, your mind removed all the celebrities which are shorter in height or not 6 foot 1 inches tall in height. But when I said he's got a French cut beard, your mind framed one particular answer and you gave me that answer. But when I said that is having the hairstyle like me, your mind went all across your data sets and was not able to figure out that particular thing or that particular celebrity. Now, this is the fourth pillar of computational thinking, and this primarily is known as the algorithmic approach, or this particular thing is known as the algorithm design, in which you structure your thoughts and bring the conditions in between in laying the conditions, and you create your structured thought to reach to a decision. This is all about computational thinking. Four basic pillars. I'll come to further sub pillars in my discussions coming up. But four basic pillars: decomposition, bringing or breaking a bigger task into smaller chunks; pattern recognition, identifying various patterns, similarities, and then creating a decision around something. Abstraction is removing the trivialities and just focusing on the information which is required, on the functionalities which is desired. And then comes the algorithm design, wherein you create a step by step structured moves to reach from point A to point B, to cite and to craft your decisions. In upcoming videos, again, I'll not be delivering theories of computational thinking. No, because I'm very firm on my thought of thinking cannot be taught, it can only be experienced. In my upcoming videos, let us together create experiences on decomposition, on pattern recognition, on abstraction, and on algorithm designs. I'll segmentize further these into activities to be done at the level of class 3, at the level of class 5, at the level of class 7, and at the level of class 9, which is the need of the hour. Because when we say that we need to engage students and give them the experience to learn, we'll have to create activities so that they perform those activities, and then they learn and understand the basic verticals of computational thinking. I am going to see you in my next video, which is going to be about decomposition. We'll first create examples in our daily life on decomposition, and then we'll move further. I'll see you in my next videos. Thank you.